The human brain mediates our experience of almost everything. It mediates our experience of the physical world, it mediates our experience of ourselves, and it mediates our experience of people in the world, so our interactions with others. What we don't know is exactly what the brain's doing and how it does it. At the University of Reading, we're interested in understanding cognitive health and well-being across the lifespan. We're interested in understanding development. We're interested in understanding damage and disease and how that affects cognitive abilities. And we're interested in decline, the natural decline of cognitive abilities due to aging. We're also interested in what we can do with that information that we learn about that. So we're interested in cognitive enhancement, cognitive augmentation, and treatment. So does changing our diet help how our brains work? Does doing brain exercises, crossword puzzles or whatever, help our brain function? Do drugs help us? Okay. So we're concerned with understanding this complex network. We're concerned with understanding how the brain develops, how it behaves through maturity and through aging. But a central question we have then is, given these interests, what do we really want to measure?
So deciding what to measure is quite a difficult question to answer. The reason for that is the brain is a complex system of coupled neurons, and the behavior of any single neuron may be only weakly coupled to the behavior of the brain. So we need to measure things on different scales. We can look on the smallest scales of single neurons. We can look on the mesoscale, where we have many neurons coupled together, or we can look on the macro scale of anatomical structures. In fact, there's a new school of studies called Neurodynamics. We seek to understand how the brain operates on a range of spatial and temporal scales. How does the brain pass around information in the form of electrochemical behavior from neuron to neuron, and yet produces a response? When we analyse complex systems, we often see patterns form, functional changes, and even whole modal changes, and these are emergent properties. They emerge from the system as a whole, and we couldn't guess them by looking at the smallest scale.
So what can we work with? We have a lot of detailed experimental data, information about precise timing and precise location of phenomena in the brain. It's possible to collect data from a wide range of people with a wide range of concerns, both subjective and objective observations about their own health and well-being. When we try and confront the experimental data with this new kind of data that's coming to us, we're faced with a very interesting problem, and that is, what is normal?
Deciding what is normal is a very difficult question. It's like our fingerprints. As embryos, we all grow limbs and fingers. We all do the same things, and yet at a detailed level, our fingerprints are highly individual. And so it is with the brain. We develop similar functions, we develop the same abilities, and yet some of that detail is a response to the stimuli we've received. So part of what we see inside a brain is highly individual, and part of it is normal. Often we define normal in the sense of what isn't pathological. So if we have a child that isn't growing at all, or a child that is growing and never stops growing, that's not normal. But within those extremes, there is a whole range of growth patterns which we would consider normal.
At the University of Reading, we're quite well placed to tackle these types of problems. We've got a range of very dynamic researchers working on a number of interdisciplinary projects, with the idea of not just finding solutions to problems, but also to define new questions. And it's those new questions which will allow us really to take the science forward. The university has invested substantially into this construction of a new center. It's called the Center for Integrative Neurosciences and Neurodynamics. In addition to an exciting collection of people, we have an exciting collection of technologies. And one special aspect of this collection is that it's been designed to work together in concert. That means that, for instance, it's possible for us to simultaneously record an MR scan and an electroencephalogram, thereby being able to look at blood flow and electrical activity in the brain at the same time in the same individual. Our perspective is that this is a new way of approaching a range of classical problems in understanding the relationship between brain and behavior, and also a way to find new avenues, new areas of investigation, and new domains of research. We have a good chance of making substantial progress in understanding this relationship between cognitive behavior, cognitive development, and cognitive decline, and the brain structures that support these aspects of our experience in the world.